Welcome to the myprojectbazaar.com. This is a project title DynamicMR, a dynamic slot allocation optimization framework for MapReduce cluster. The modified title Efficient framework for optimized allocation of slots for MapReduce mechanism. This is the abstract of our project. In our process, we are going to perform the dynamic slot allocation in the MapReduce paradigm. In cloud computing, MapReduce is the current computing standard for important data processing. But those existing techniques in the process are not providing the better performance because of the unimproved resource allocation. The resource allocation is one of the major problems in the MapReduce paradigm. To overcome this issue and to provide a performance improved resource allocation, here we propose a mechanism called DynamicMR. In a DynamicMR, we have three major steps. They are dynamic slot allocation. It is used to overcome the slot allocation constraint. Second one is a speculative execution. That is, it performs the load balancing. It is to steadiness the performance in the cluster of jobs. Third one is a slot pre-scheduling. It is to advance the data visibility. Nothing but for the data locality process, we perform the slot pre-scheduling process. Finally, it improves the performance of the MapReduce workloads by applying the three mechanisms. We improve the performance of the MapReduce cluster via optimizing the slot utilization, primarily from the two perspectives. One is from a dynamic slot allocation, another is from a slot pre-scheduling. This is the DFT of our process. First of all, we load our dataset. After loading the dataset, we perform the pre-processing process. Then after the pre-processing, we start the resource allocation process. The resource allocation should be a optimized one. For that, we apply three types of mechanism. First mechanism is a dynamic slot allocation. It is nothing but dynamic Hadoop slot allocation. Here the utilization of slots takes place. Here the map slots and reduce slots are dynamically allocated for our system. Second thing is a speculative execution. Performance balancing. It is for balancing the performance, which balance the running time of the background jobs on our current running job. Third one is a slot pre-scheduling. In the slot pre-scheduling, it also balance the slot allocation for the map and reduce based on our input data. The main objective of the slot pre-scheduling is to improve the data locality. After performing the three types of operations, we are going to perform the optimized result by identifying the optimized resource allocation. Finally, our output is the execution time. Let us see the demo for process. For our process, we will first open the VMware and log in into the VMware with the username Hadoop-user and the password is a Hadoop. Then open the Eclipse. The Eclipse, our process is a DynamicMR. This is our process. In this, right click the start.java. Run as run on Hadoop. Select the choose existing server. Finish. This is our home page. First, browse the data center. This is to select our data set. This is our data set. Data set loader. Proceed. Display the information in the data set. After showing the information, the pre-processing is necessary. Proceed. Then remove the redundant data. Then show the pre-processed result. Proceed. It shows the difference before pre-processing and after pre-processing. Results before pre-processing, results after pre-processing. Then again enter into the Eclipse, right click the node HTTP run as run on Hadoop. Finish. Then it is a data description. Then load into HDFS. Our data is loaded into the HDFS, which is nothing but the Hadoop distributed file system. File uploaded successfully. Proceed. Slot allocation takes place. We can able to dynamically allocate slots here for processing. So I allocate the slots. After the slot allocation, slot storage takes place. Next, the mapping process takes place. File uploaded successfully. The mapped results. Next, slot allocation takes place. Map slots is 3, reduced required slot is 1. After borrowing, the slots become like this. Then we are going to run our process, that is we perform the word count application inside the each data center for a individual map jobs. This is a map reduce execution. This is the map reduce execution for the 5 input jobs. This for the first input job, execution time. The map reduce execution. Then we proceed the same process for data center 2. Finally, it shows the execution time. From that execution time, it shows the optimized path. Then proceed. Then it's a graph for the data center 1, data center 2, data center 3. This is a evaluation, that is a optimized execution time. Thank you.